Okay, hello and welcome to another section in further mathematics. Today we'll be talking on limits of numbers. But before we continue, I'd like us to make a quick review of what we studied in our last lesson. Okay, welcome back. When we're talking about limits of numbers, limit, the word means bound. That's the boundary of the number. Let me say, for example, you want to talk about, if I should tell you that the limit I want is 50, that is to say, I don't want a number that is above 50. The number should be within this range. Now, when you're talking about limit of numbers, there are things that you really need to take into consideration. Now, limit simply means boundary, or you call it standard. You're giving this person this limit, means you're giving the person a particular standard that he or she should not exceed. So when you're talking about limits of number, from what we're seeing in front of us, we have certain laws that governs operations in limits. For example, we say if L, M, and C, K are real numbers. So we have 4 real numbers. 1 is L, 2 is M, 3 is C, and 4 is K. Let's take them all to be real numbers. And limit fx, where x turns to c, is L. So we are now making this limit to be this. That's to say, whenever you see limit of fx where x turns to c, you replace it with L. And when you see this, you replace it with M. Then let's go to summation rule. Now, summation rule in limit states that when you have lim f of x plus lim g of x is equal to L plus M, that is to say, respective limit, you can still go into writing it as lim. You can go into writing it as lim. This lim is short form of limit. X implying c of fx plus lim x implying c of gx. So this is equivalent to this. So that is to say, when you have a limit of this nature, you can add the sum of the respective limits to get the values. Now, when you get, this is the difference rule. When you get a limit of numbers, let me say a lim fx minus gx, you can write it as L minus M, or you can still place it as lim x tends to c minus lim x tending to c, and here becomes your gx. Yes, the concept behind all this is your ability to form or create the sum of these limits, or forming the difference between the respective limit. But whenever you have a limit of a constant, then the limit of the constant is a constant itself. So when you have something like lim as x tend to c of k, then the answer becomes k, because the limit of a constant gives you the same constant. Now, that of the quotient that says lim c, when you have f of x being divided by g of x, you can still divide it by the respective limit by saying lim f of x divided by lim g of x. You get the value of this and you get the value of this, but your g of x must not be 0. This is because when you divide lim f of x with lim g of x by 0, then you will now have what is called a math error. numbers are not being divisible by 0. So each time you want to perform operation on limits, you make sure that the number in the denominator is not a 0 term, in order for you to have an interval of numbers. Now we have to talk about the power rule in limits. Now when you're talking about the power rule in limit, you talk about the operations. Like, let me say if you have lim 5x3, and where the lim turns to 4, where x tends to 4, what you're trying to say in this point is that at each point, whenever you see x, you replace it with 4. So this becomes 4 raised to power 3, and 4 raised to power 3 is equivalent to 4 times 4 times 4. 4 times 4 is 16. Then you now do 16 times 4. 4 times 2 is 24. You have 4 and you have 2, so it's 64. So this is equal to 5 times 64. So that is it. Then when you have the power term, you raise it to this and you have the n positive integers. But if n is even, we assume that the limit of fx as x tends to c is greater than 0 at each point. Now I would like us to use the basic laws that we are seeing in front of us now into solving several questions in limit that will aid us in a proper understanding of the concept that we've just discussed. Now let's solve this. Question 1. This is question 1. Evaluate lim x as x tends to 0. You now have, this is the limit, 7 minus 2x plus 5x squared minus 4x cubed. Now remember the rule. The first step is for us to change x to 0. That's to say, that's the limit. Remember I told you that limit means bound. So you replace x with 0 in this equation. So you state your solution. After stating your solution, you start. So the lim as x tends to 0 then becomes, we have 7 because there's no x here, minus 2. Then there's x, you put 0 in place of x, plus 5 in place of x, you put 0 all square, minus 4 in place of x, you put 0 raised to power 3. So therefore you have 7 minus 2 times 0 is 0, plus 0 square is 0 times 5, which is still 0, minus 0 cube is 0 times 4 is 0, times 4 still gives you 0. So here we have it as 0. So with this, 7 minus 0 plus 0 minus 0 is 7. So therefore lim 7 minus 2x plus 5x squared minus 4x cubed as x tends to 0 is equal to 7. Okay, I would also like us to try something else. Let's do this. Question 2. Let's say let's evaluate lim as x tends to 0 of x squared plus 5x plus 9 over 2x squared minus 3x plus 15. Now in dealing with this, let's start by changing the first step, just like what we did here. The first step is changing all the x to 0 term. So we now have 0 squared plus 5 times 0 plus 9 all over 2 Then we have x here, so you now put 0 square minus 3, there's 0 here, times 0 plus 15. So with this, 0 square is 0 plus 5 times 0 is still 0 plus what? 9 all over 2. 0 square is 0 times 2, 0 minus 0 times 3 is 0 plus 15. So this 0 goes off, and what we are having here is 9 over 15. And 9 divided by 15, 3 into 9 is 3 times, and 3 into here is 5 times. So our final answer is 3 over 5. So that is to say, lim x square plus 5x plus 9 all over 2x square minus 3x plus 15 as x tends to 0 is equal to 3 over 5. And that's the answer. I'd like us to solve one more question on limits. So let's do this. Question number 3. If we have find the limit, let's not just use this. Let's say evaluate lim as x tends to 5. This time x is not turning to 0 again, it's 5. Of x squared minus 25 all over x minus 5. So you remember that when we did quadratic equation, I said when you have an equation whose highest power of unknown is 2, is quadratic equation. Now you solve it. So let's do miniature work here by saying x squared minus 25 is the same, is equal to, is then x squared is equals 25 plus or minus 25. So x is equal to square root of plus or minus 25. So x is equal to plus or minus 5. So x is equals 5 or minus 5. Now if we bring it here, we now have x equals 5. That's this. We now write x equals minus 5 over x minus 5. But let's start bringing this to this other side. We now have x plus 5 and x minus 5, because it's all equals 0, all over x minus 5. So with this, you see that x minus 5 goes with x minus 5. You now have x plus 5. Now coming back to our limit, remember we say x tends toward 5. So you now put 5 in place of x from this equation. We now have x as 5 plus 5, which is equal to 10. We now state clearly that lim x minus 5 x squared minus 25 over x minus 5 as x tends to 5 is equals to 10. Thank you for joining us in this lesson. In order for you to always refresh your memory on what we've just discussed, please always take the test that will appear on your screen. Do well to always consult these same lesson notes on the platform for a better information on the topic we've discussed. Always feel free to drop your questions, your comments, and if you have a contribution, you can also bring it up in the comment section. We'll be so happy to hear from you. Thank you.